Okay, everybody, welcome to my channel. My name is Ryan. This is all about analytics, and I talk about all kinds of different topics, almost anything you can imagine, and probably a whole ton of stuff that you could never imagine too. So today I wanted to talk about solid waste collection and how we can do the routing of trucks to be able to prepare to pick up all the waste, right? All the garbage, you can call it garbage if you want, across any network or any predetermined path that you choose, right? And to make sure that we pick up all the trash and it's efficient too, right? So we try to optimize the process. So that's the topic for today. And why do we even want to talk about something like this? It's very relevant. First of all, everybody has garbage, right? Every single day, virtually every single day. Somebody throws something out, probably every hour during the day, somebody somewhere is throwing something out, right? So there's a lot of garbage out there. It needs to be disposed of and handled, right? So how do the garbage trucks handle this massive demand, right? That has been established. So takes a lot of work, takes a lot of effort, takes labor too. They want to save time, they want to save money, they want to save resources in terms of fuel burned, right, and time consumed, right? When today is over, you will never have today back. A lot of people don't understand that concept. But today is what? um, November 4th, 2025. There will never be another November 4th, 2025. When the day is done, it is done. It's not coming back. Some people don't get that, but that's a fact, right? Like today is today, and when it's over, it's over. So saving time, resources, and saving money. Money is fuel, right? Time is money too. Money is time. Time is money. So reduce operating costs overall. Lower maintenance of trucks, fewer miles driven means less wear and tear on the engines, on the brakes and tires. Okay, this goes without saying, pretty much common sense. Um, Fleet resizing, right? If you don't do this efficiently, you're going to have to hire more trucks and more human resources, more people to pick up the trash, right? If you do it right, you can do more with less. Okay, sometimes less is more. Literally, I'll prove that today. Less is more, right? There's an environmental impact that we have to be aware of, so that's important as well. Fewer vehicle kilometers driven or miles driven, depending where you live in the U.S. or outside the U.S. Right? That same duration of driving, right? Duration is the same wherever you are, whether it's miles or kilometers. Quieter, smoother operations, overall intelligence. Like, how do you do this smartly, right? I've worked with a lot of people in my career. I've been in Wall Street for over, I think, 22 years now. I've worked with a lot of people. There's a lot of smart people out there. There's a lot of dummies too, right? You have to try to present an air of sophistication. You're intelligent. Maybe not Abraham Lincoln. I think it was Lincoln once said, what was it? It's better to remain silent than to open your mouth and remove all doubt, right? So if you are silent, people could say, that guy over there is kind of quiet, but he could be pretty smart. I just don't know. But if you open your mouth and say a bunch of dumb stuff, people are going to know you're not a smart person, right? So the point is overall operational intelligence. You want to be smart about how to do this. Again, saving time, saving money, saving resources, natural resources, human resources, just saving resources. So let me go ahead and move down here. That's the setup, right? Here's the pitch. So I'm going to go ahead and import these libraries. I have a couple parameters I'm going to use over here. So I set these. I'm going to look at 3 different geographical sites, okay, 3 different metro areas: Park City, Utah, Seattle, Washington, and San Diego, California. So I set this up into a list. This is a list identified by the square brackets. Typically in Python, you'll have objects such as lists, dictionary, which has key value pairs, tuples. I've worked with tuples before. I don't work with too many tuples. Some people like it. I'm not a big fan of that. I think lists, dictionaries, and data frames, for the most part, get the stuff done. I don't use a whole lot of tuples, but that is another data object in Python that people lean on. So I have the list here. I have my parameters down here. Let me go ahead and hit Control Enter. It does take a little while to run this code. You can see in the top left corner over here, the hourglass is running. Okay, so we just kicked it off and we are in business. So let me go down here and just show you how this thing works. I will talk you through it. I'll give you all the narrative right here. And I'll probably have to hit the pause button because this does take a little while to run. It does take several minutes, but everything is automated, right? Automation is a big thing nowadays. They're talking about automation and AI and all this stuff. I've done this for 20 years. It is pretty important. It's not the be all end all. And I guarantee you, when you kick off your automation and you can do 40 hours worth of work in 15 or 20 seconds, right? That's reality. I've seen that many times before. You go into a job site, takes this guy 40 hours to do the work, you do some code, then all of a sudden you can do it in 20 seconds. Your work will expand. You'll get more on your plate as you go. It's not like you go into the office at 9 o'clock Monday morning, click a button, and by 9:01 a.m. you're heading home and you don't go in Tuesday through Friday. It doesn't really work like that, right? When you automate your task, you have 40 hours worth of work. Now it's done in 20 seconds. That's great. That's fantastic. They're just going to give you more work. That's what happens, right? It's not like you just don't show up anymore and you just get the paycheck. No, you still have to work. So automation is great. So everything is automated here. I clicked the button, well, the button per se, it's really Control Enter to run the code in the cell. It's going to loop through the 3 metro areas that I just described, and it's going to produce the results, right? So it shows you the optimal path to go ahead and pick up all the trash all around the city in these 3 metro areas. And if you want to add more things, by all means, you can add more, right? I live in New York City. Well, I have to put quotes right because this is a string here in New York. New York, USA, United States of America. God bless America. So if you want to put in more, just put in more to the loop. Okay, that's all you have to do. So everything is automated here. Everything is running pretty fast, pretty efficient. It does take a few minutes, so I'll probably hit the pause button. But before I do that, let me just take you through some of the nuts and bolts here. I am creating a UDF. So this is a user-defined function to go ahead and get different coordinates around the city. How can we plan this in an optimized fashion so we pick up all the trash around the city in the main trash areas? Okay, so these have been predefined. The code goes ahead and looks at the city, looks at the main points where the trash would be picked up in the city, and plots the routes for all the trucks, and plots how many trucks are going to be sent out to, right? How many trucks will be deployed. In a bigger city like New York, obviously there's gonna be a lot more trash to pick up, lots of garbage everywhere, and you're gonna need more trucks and more people to do the job. In a smaller city like Park City, Utah, it's just gonna be less trucks and less people, right? So that's what the code does. It looks at the city, it understands like what the demand is in terms of garbage collection, what is the overall need, what are the critical points for these vehicles to drive on to pick up the garbage, and how to do this in an optimized fashion, right? So we use a few different things. It's called a polygon, which is a multi-sided shape or multi-shaped object. So it looks like the polygon that defines the city, right? So all cities have perimeters or borders or something like that. Either you're in the border of the city or you're not, and it's not just trapezoid or not trapezoid. I'm sorry. It's not just like a rectangle or a square. Forget trapezoid. No city is shaped like trapezoid. It's not just a square or a rectangle. It's probably not a circle. Although some cities kind of are shaped a little bit like a circle. I lived in Corona, California many years ago. The nickname was a circle city. It kind of looked like a circle, but nothing is like a perfect shaped object. Everything is more or less like polygons, right? Different shapes of these objects. So we have to get the polygon shapes. We have to get minimum maximum distances of all the coordinates, all the driving paths around the city. And another criteria too is we have to follow the natural contours of the streets. Okay, these can be called corridors. You have to follow the corridor that a vehicle will drive on, right? So if you have twists and curves and turns in the roads, the vehicle pretty much has to follow that path. Now, I've got this pretty much optimized so it follows the general path of the street. Sometimes you'll see like little kind of dogleg curves to the left or to the right. It's not getting down to the millimeter precision of the street, right? It makes a couple deviations here and there, but I think you can figure it out. You can see the path and the optimized path that these trucks would follow to be able to collect all the garbage in the minimum time and the minimum distance traveled as well. Okay, so we have the polygon set minimum maximum coordinates. We have latitude and longitude coordinates set. Okay, so everything is set up right here and passed into this UDF defined as load sample stops. So these are the samples for the garbage trucks to travel on, the routes that they travel on. We look at all the IJ coordinates and the links between those coordinates. Okay, so ij basically says, show me all the rows in the entire matrix. We're creating a matrix and looking at all possible combinations and looking at the shortest distance that needs to be traversed or traveled and hit all of these coordinates, right? So i's is showing you all the rows, the j's are showing you all the columns, and you look at every single possible combination of column and row. So you can think like maybe 10 by 10 square. No, again, no city is shaped exactly like a square, but we'll have these polygons just to simplify like how the calculation is set up and executed. We'll have maybe 10 columns, 10 rows. So we look at one by one, 1 and 2, 1 and 3, 1 and 4, and so on and so forth, and 99 and 98 and 99 and 99 and 99 and or 100. I think that's how it ends, right? So 10 by 10. So it goes through all the possible combinations. That's what the INJ does. So once we get that, we can go ahead and create a network graph. This NX graph is literally a graph of the city, of the metro area. Again, we're looking at San Diego. We're looking at Park City, Utah, and I think the other one was Seattle. I think those are the three that I picked. So we're looking at network graphs so we can understand the layout of the city streets. Again, we have to see how the city streets run, north, south, east, and west, how they deviate, how they curve and turn around like that, going over bridges, going through tunnels, going around whatever it is, a landmark or a big mountain or something like that. We have to understand the contours of the geography and the designs of the streets, okay? With the exception of Manhattan, not too many things are perpendicular to each other or parallel to each other, right? There's a lot of back and forth and switchbacks and so on. So this is what the network graph does for us. And by the way, that's how Google Maps works too. I have a video on my channel. If you're interested to see how Google Maps works, you can check that out. Everything is designed on network graphs, how to get from point A to point B. If you are going to deviate and run a couple errands in between your work and your home, if you're going home and you have to go to the grocery store and maybe pick your kid up from the daycare center or something, that's how Google Maps plots everything for you. They use network graphs, okay? So in my video, I explain that. So we have everything pulled together and we have to look at all the parameters. Again, we're looking at all the ij coordinates, right? That is the matrix that you see down here. So we're looking at every possible combination, looking at the shortest distances from point A to B, B to C, C to D, and so on and so forth until we get to the end. And then again, we have to follow the contour of the street, okay? You can't just go in a straight line. If you're a bird or an airplane or a helicopter, right? You can probably travel in a straight line. Probably boats can do that for the most part, but the boat still has to follow the river. If you're in the middle of the ocean, I guess you can go in a straight line. But cars can't, right? And garbage trucks can't. We're looking at solid waste collection. You have to follow the route of the road, okay? So that is a prerequisite. So now we have the basic framework set up here. Now we have to look at the time it's going to take for this route. How long does it take to go from point A to B, from B to C, C to D, and so on and so forth? So we're looking at the optimizing the route and minimizing the time. Okay, and we're going to deploy a few different trucks. This is just not one truck that drives all over the city, back and forth and back, up and down, left and right, and picks up the garbage. Is several trucks. So we have to deploy the trucks so each one is optimized and they don't overlap on other trucks' routes, or if they do, it's bare minimal. Maybe you'll cross the street, maybe there's some small intersection or something like that. But you don't want one garbage truck following another garbage truck that follows another one that follows another one. That makes no sense whatsoever. So you have to deploy them so the garbage trucks are optimized and not interfering with other garbage trucks' routes, because that's just wasting time and resources, okay? So when we do that, we need another function to understand the layouts of the streets, right? Like I described a moment ago, the streets have contours, they have curves, we have to follow the street, keeping in mind that we want the shortest path and the shortest time. Now, when all of that is set up, we can take all of the calculations that we've done and plot that onto a map. So when we plot that onto a map, we can see visually what this plan looks like. So when we execute the plan for a solid waste collection, which is just a nice way of saying garbage pickup, right? You're just picking up garbage. That's literally what it is. How how many trucks are going out, what's the route, how they do this in the shortest time, and the shortest distance traveled, and thereby save the the people's time, so they're not picking up garbage for 8 hours if the same job can be done in four. Just finish it in four. Why would you take eight to do something that you can do in four? It makes no sense, right? And save resources, less gas, less oil, wear and tear in the brakes, wear and tear in the tires. The resource management has to be optimized as well. So we do all of that and we plot this on a Folium map. So that's what this part is for. Everything is loaded in different layers into an M variable. M is just short for map. I just use this as an abbreviation for map. And by the way, if you've never used Folium maps before, that's totally fine. I get it. I understand. At one point when I started using this stuff, I think I got into Python about 13 years ago. I didn't know what a Folium map was at the beginning either, but these are very fascinating resources. You should take a look. Google it. You're going to learn a ton. Folium maps are great for understanding very granular level details of roads all across the United States, all across the world. They have maps in every country I've ever seen. I can't say every single country in the world has a Folium map rendering, but everyone I've tried, I've always found it. So I'd say pretty much every country, or maybe every. I can't speak to that exactly. Um, but very good coverage and very good details of pretty much any city or any country that you want to find a map for, you can find it. Okay, so we're taking all of that and putting it into this function where everything is executed and thrown into all of those helper functions that I described before. So we get the network nodes, right? That's showing us how we can drive and how we can navigate on all the paths, all the streets. How we can do this in an optimized way. So shortest distance, shortest time, less resources, less man hours, less fuel, less oil used, right? So everything is optimized. We have all the addresses, all the labels of addresses, right? So we have like a street address, but not just that, we have like a little bit more description about the address. If you just say like 1010 Southwest Street, okay, do I really know what that is? I probably don't unless I live there or unless I drive through it every day. So the label gives us a little more description about what's going on, okay? And we have latitude and longitude and then the name of all these stops, right? So with the address, the label, and the name of the stop, we get a lot more description. With the latitude, longitude coordinates, we can do this just with these two, but it wouldn't be as meaningful to the average user, right? You want meaning, you want depth, you want description. I worked in a place years ago. It's kind of funny. The company had hundreds and hundreds of models, and they had some people going in helping them with the business. I'm not going to say too much about this, but they started identifying and describing all these models, looking for inefficiencies or what was it called? Validation. They had to validate how the models work. So it's funny. They said, okay, this is model one, this is model two, this is model three, four, five, six, seven. Got up to 10, and somebody said, "Whoa, what is model one? What is model two? What is model three? I don't know what this is." Like, you have to give me something that's descriptive of what the model does. This is a risk management model. This is a valuation model. This is a pricing model. You have to tell me what the thing is, right? So that's why we have these descriptors over here to inform just a normal person what this is. With latitude, longitude, okay, we can get precisely the pickup spot for all these garbage stops where the truck is going to stop to pick up the trash. But without the description, does it really mean a whole lot? Does it really have purpose or intention? No, right? So you have to have some kind of description there. So, so we take all of that, then we get to the total minutes to execute this. And again, we look at all the I and j coordinates. We look at this in the matrix. I have an example right here. Where did it go? Where's my I and j? Where was I? Sorry, before. Yeah, so we do look at every possible combination of time to transverse the entire geography of the city. Where's the I's and J's? Sorry, I just saw it. Okay, yeah, so we're doing that, and the nodes. Okay, so we have the coordinates there. Where the heck was it? Okay, sorry about this. I saw that before. Where the heck is the matrix? Oh yeah. This is it. Okay, so we look at every possible combination of time again, and then optimize that. So if we drive from A to C or A to D or A to E, and then go to B, would that be more efficient? Yes or no? Or is it more efficient to go A, B, C, D, E, or maybe even A, E, B, C, D? Maybe that's more efficient. That's why we look at every possible combination of everything and find the shortest distance for all the paths that need to be transversed. Okay, so we get everything into a list called summaries. If I look for this, we see the list right here. This is how I do pretty much all my videos. 99, maybe even 100%. It's always done the same way. I think it's very efficient, very straightforward to do it this way. Pretty polished, pretty professional. This just looks nice and it works pretty well. So I try to create lists and then do all the appending to the list. I think this structure works very well for me. I think this is a pretty common way to do it in the business. Although I don't think I've ever worked with another Python program in my life. I just learned all this stuff by reading books and just like on the job training. But I would assume that most people do it this way. I'm kind of a lazy person and I don't see any point in working too hard and I try to do things as efficient as possible. And for me, this is the most efficient way. If somebody knows of a more efficient way, then let me know. But I think this is the fastest, most efficient, and laziest way to do it and still execute and still get it done. So I can see that this is still working. We have Park City, Utah, Seattle, Washington done, and now San Diego is being prepared right now. So we hit the pause button. I'll be back in a few minutes. Again, this does take a few minutes to run. That's just the way it is. It's doing tons and tons and tons of work, right? And everything is automated. Just hit Control Enter to run the code in the cell. And by the way, I'm going to share all this code with you guys. You can download that from my Google Drive. I'll share a link to the file. You can download all the code and run this yourself. And of course, put in other cities, right? If you want to see like whatever, St. Louis, Missouri, if you want to see Boston, Massachusetts, if you want to see New York, put that into the list and run it and you'll get your own city, right? So that's it. Very simple to set up, very simple to use. I'm gonna hit the pause button. I'll be back and show you what the final product looks like when this thing finishes up. I think it's 2/3 done, but I don't want to just sit here and just burn through time and make you watch that. So I'll hit the pause button. I'll be back in just a bit. Hang in there. Okay, so at this point, everything has finished off. We can see the final results here. So, Park City, Park City, Utah, 110 stops and 5 trucks, and capacity per truck is 22. So like 22 garbage cans, right, to fill the truck. These are pretty big. I think these are like 60 gallon cans or whatever that thing is. Sorry, I've had this acid reflux for 10 years. I cannot get rid of this. All it does is make me cough and wheeze all day long. So we have day one, 110 stops, 5 trucks, capacity 22 of these 60-gallon tanks. Day two, pretty much the same. Okay, we do 2 simulations. That is for Park City. For Seattle, 110 trucks, okay, capacity 22, and we see the routes in Seattle. Okay, and this thing is pretty much optimized, almost the same thing. So 110 stops, 5 trucks, capacity is 62. I guess the size of the truck is pretty much standard and pretty similar, and they've optimized this to 110 stops where most of the garbage can be collected in an efficient manner. Let's see what this looks like if I go over here. By the way, everything is saved in a folder or subfolder called output. Outputs, I think that's it. Outputs, right? So everything goes here to this folder, and this, by the way, is my default folder where I installed Anaconda, so everything is saved here. Yours will look pretty similar. You'll have C users, and then the name of your computer, whatever you named yours. Mine is Ryan. Yours probably different. Could be the same if your name is Ryan too. And it goes here to outputs. So that is why we're looking at here. If we look at Park City, Utah, the first simulation looks like this. Okay, so we see truck number 4 has 22 stops. These are the stops, and pretty much follows the contour of the street. This is what I mentioned before. It goes off a little bit. It kind of cuts a corner over here. You can see it's kind of like a straight line because it's not going like centimeter by centimeter or millimeter by millimeter, right? So it tries to make this a little bit more efficient. Obviously, the truck is going to follow the contour of the street for the most part. Okay, that's the first plot, and then you have the first truck. This is the route for vehicle number 2. This is vehicle number 1, right? This is vehicle number 4. This is vehicle number 2, the one in orange, and you can see there is a little bit of an overlap, like this orange and purple overlaps a little bit, but it's pretty minimized, right? So the model has determined that the purple goes pretty much in this straight line. Everything starts and stops here. This is kind of like the depot, the recycling depot center or garbage pickup center. And the orange and the purple overlap a little bit, and the purple and blue overlap a little bit, but it's pretty minimal here, right? And you have your own separate and distinct routes. Looks like green and blue overlaps a little bit, but for the most part, green is separate. That's what we would expect, right? We don't want the route to be mostly overlap, right? I can understand if there's just a little overlap because you can't have just totally separate routes and force the trucks to drive way out of the way to go around if it's just easier, quicker, and cheaper just to go a little bit on the same route. But they're not going to be picking up garbage on the same route, right? The overlap would be the streets that the trucks drive on. So let me look at the second simulation over here. So number 2, okay, so we have route or vehicle number 4 over here. This is vehicle 1. This is vehicle 2. And what do we have? 5 over here. And this is probably 4. Oh, 3. All right, that's 4. This is 1. Oh, 4 is red. Okay, so that's Park City. Okay. Let's look at a couple more. Let's look at Seattle. Let's see what Seattle is doing over here. Seattle is right here. Okay, so open this guy, and we can see that it's definitely Seattle. I've been there before on a short vacation. That's definitely what it looks like. So these are the garbage routes, with this being the route for vehicle 4. This is vehicle 1. This is 5. Orange is going to be 2. And this is probably 3 over here. Yep, 3 is in green. So that's simulation 1. Let's look at the next one over here. Okay, so this is the garbage pickup center. So they start and end over here. This is day 2 simulation. So this is vehicle 4, 3, 1. Purple is 5, and this is going to be 2 over here. So orange is 2. And again, you see a little bit overlap between the orange and the purple, but it's pretty minimal. So that's fine. And then we had one more city that we analyzed, right? This is San Diego. So let's see simulation number 1, what that looks like. So here's SD over here. Okay, so truck 2 goes in this route. Truck 3 goes over here. Number 5 goes over here. This is what, 1? Yeah, that's 1. And this is the last truck, truck 4. So it follows these routes, right? And if we look at one more simulation over here, we will see San Diego. The next map, I'm calling it day number 2. It's really like simulation number 2. So there's San Diego again on my Folium map. Again, Folium is great. You can zoom in here and see all the details of the streets. So I see East Street, I see Park, Highland, and 11th Avenue, and Broadway, and so on and so forth. And you can see all the buildings in between here. All right, and obviously the contours of the streets. This is the path that the trucks will follow. So this is truck number 2 in orange. Green is 3. Red is vehicle 4. I have a blue and a purple over here. So blue is vehicle 1, and this is what, 5? What's left? 5 is the last one, right? So you can see this is how we optimize garbage collection, right? Following the contours of the road, minimizing resources, including human resources, natural resources. So fuel, oil, wear and tear in the trucks, on the brakes, to minimize the distance traveled, but still get the job done in a very efficient manner, right? So that's the point of doing the simulation and the modeling. So that's it. I'm going to share all this code with you. I will download this as an HTML file, and I will share that with you when I share the video. I'll post that a little bit later today, and you will have everything you need to do your own simulation. And of course, feel free to change the code, make changes, modifications, updates, improvements. Let me know if you make some significant improvements and you get the trucks to do even different things, right? Maybe adding more trucks, maybe adding more collection routes. Okay, I know not all of the streets were driven on, but the point is to get like the most of the garbage picked up in the minimal amount of time. So if you add more routes, it's going to be more trucks, more people, more time, right? But more garbage collection too. We're trying to pick up the most garbage and the least amount of time. But we didn't get to every single street, right? There's going to be some smaller streets that in this simulation get passed over. I think that's okay. We have good coverage here. We got most of the trash cleaned up. Maybe there would be another crew that goes out. Maybe this is like a Monday or Tuesday pickup schedule, and maybe those are the major pickups, and maybe we can do like a Thursday or Friday kind of schedule and go to those smaller streets and those inside of those communities where the main trucks didn't access at that point. Okay, so there's ways to improve this. I'm sure there is, right? This is my first pass at this. I think it's good coverage. I think it pretty much covered like everything I wanted to in the video. But of course, you could always spend more time, make a couple more improvements, a couple refinements, and maybe crank this up a notch, right? Or level this up to something just a little bit better. So if you want to do that, feel free to do that. Okay, I'll give you all the code that you need, and I'll post a video later today, and I will come up with some new videos, and I'll post those in the coming days and weeks and months. So keep an eye out for that. Thanks for your time. I appreciate that. Hopefully this was educational and inspirational for you. And I will see you when I post the next video, which should be pretty soon here. Okay, so hang tight, and I'll talk to you soon. Bye.